Morning everybody. Today we are going to talk about scatter plots again. Before we get into any of that though, we're going to just do a quick review. A scatter plot is a graph used to determine whether there's a relationship between the paired data. Scatter plots can show trends in our data. So if our y tends to go up as our x goes up or increases, they're said to have a positive correlation. If our y tends to go down while our x goes up, they have a negative correlation. And if they're just random points on our graph or they have no relationship, then we can say they have no correlation. You can always remember this by positive is going uphill, negative is going downhill. No correlation is just random points on our plot, our graph here. So another review, we're going to make our own scatter plot here. So what we have first is we need to label these points on our graph. We have x as -3 and our y is 1. So we need to graph -3, 1. So we're going to go to the left, -3, so 1, 2, 3. Then our 1 is positive, so we're going up. So 1, 2, 3, up 1. Here we have -2, -1, so the left 2, down 1. Left 2, down 1. Here we are going left 1, -1, and down 0. So -1, 0. Here we're not going anywhere, we're staying at 0, but then we're going down 2. So 0, -2. Here now we're going up 1 because it's positive, or not up 1, sorry. Got mixed up there. That should be, instead of left, going to the right 1 and down 4. So to the right 1 and down 1, 2, 3, 4. Here we're going to the right 2 and down 5. So the right 2, down 1, 2, 3, 4, 5. So now that we have our points labeled on our graph, we can draw a line of best fit. So we're just going to draw a line through our points. What that is our line of best fit. It shows us that the trend in our data, so we don't have to continue to draw our points. It's going downhill, so it's a negative correlation. Excuse me. Now it says approximate the value of y when x equals 3. So what we need to do is we need to go over to 3. So 1, 2, 3 on the x-axis. Then we need to go down to find our line, because our line is below the 3. We're going to go down all the way till we get to our line, which is maybe about there. Then we're going to go over to our y-axis to see where our y would be about. If this is -5, this is -6. So we'll say that y is about -6.5. It's about 6.5. If you wanted to say y equals -6, that would probably be okay too, depending on where you draw your line. But as long as it's close to -6.5, we're good. Now, today we are going to learn some new things, but we're going to be using some old things to do these. We are going to be finding equations from our scatter plots. But to do that, we are going to use some forms that we've already done before. So we are going to be using this form right here. If you remember what that form is called, it's called the point-slope form because we have our slope here and then our 2 points, x1 and y1. So it has a slope and a point. Then we're going to be changing this into our slope-intercept form. We have a slope and we have a b, or a y-intercept. So how we are going to do this is we are going to pick 2 good points on the line. When I say line, I mean the line of best fit, and label them x and y. So if we have a graph that looks like this, and we have a bunch of points, just our scatter plot, and we have a line of best fit, what we're going to do is try to find 2 points on this line. All these points are off the line, so we need to make sure there's one on, or we can make them, just make a point on the line. Doesn't matter where. We're going to find 2 good points on the line and label them x, y. Then, after we do that, we are going to find the slope. So, we can either find the slope with m equals y2 minus y1 over x2 minus x1, or we can count it. So we have m equals rise over run. Because once we have 2 points, we'll be able to count it out by doing our rise and then our run. Once we have our slope, we are going to write an equation in point-slope form, which is right here. This is point-slope form, and then convert it to slope-intercept form, which is this. We know how to do that, but let's do a little review just so we remember. We have done it before, but if you're like me, you forget easily, so we're just going to do a little review first. Alright, so here we have a line. We have 2 points on it. We need to first label our points. So here's our point 1, right here. We need to figure out what that is. So we need to label it x, y. First we need to go over x, 1, 2, 3, 4. So x is 4. And our y is 1, 2, 3, 4, 5. So that's our first point. Our second point is over 1, 2, 3, 4, 5, 6. And then it's down 1, so our y will be negative 1. Alright, we labeled our points. Check. Now we need to find the slope. We could find the slope with y2 minus y1 over x2 minus x1. But these are pretty easy points, so we can just count it. The line is going downhill, so our rise is going to be 1, 2, 3, 4, 5, 6, negative 6. So our m is negative 6 over our run, which is 1, 2. Negative 6 over 2 simplified can be written as negative 3. So our slope is negative 3. Alright, we found our slope. Now we need to write an equation. So what we're going to do is we're going to write it in our point-slope form. So we'll have y minus y1. We'll say y1 is 4, or 5 I mean, because this is x and y. So y1 is 5. Equals our slope, or our m, which is negative 3, times our x minus x1, which if this was y1, this would be x1, which is 4. So that's our point-slope form equation. Now we need to convert it into slope-intercept. So what we need to do first, if you remember, is to get rid of these parentheses. We get rid of the parentheses by drawing a box. On top, we're going to have x minus 4. On the side here, we're going to have negative 3, because our negative 3 is out front. So negative 3 times x is negative 3x. Negative 3 times negative 4 is positive 12. So if we bring these down out of our box, and bring that y minus 5 down, we have y minus 5 equals negative 3x plus 12. To get y by itself here, we have to add 5, because it's the opposite of minus. And we're going to add 5 over here, because they both don't have variables on them. So we get y equals negative 3x plus 17. So this is our slope-intercept form equation. We have y equals negative 3x, negative 3 is the slope, plus 17, 17 is the y-intercept. So this is what we're going to be doing today. We're going to be finding equations and converting them. Here, as you can see, we have a scatter plot. And we have points. We have a best fit line, but our points are not on the line. We need to find points that are on the line. This one is close, but not quite on. This one is also close, but not quite on our line. So we need to make these points because none of them are on our line. Our first one we could make could be right here, because that is on an intersection of our graph. There's one right there. We also, this one is close but not quite, close but not quite. Here's one that we could put on because that's on the intersection at 0. So we'll have a point here and a point here. Alright, first of all, we labeled our points. We're done with that. Now, well, let's actually put these as x and y. So this point up here will be over 1, 2, 3. And up 1, 2, 3, 4. So 3, 4. Here, this is on the origin, so it's 0, 0. Alright, now that we labeled our points, we can find the slope. Since we have two nice points that are pretty close to each other, we can just count it up. It's going positive, so it's going to be a positive slope. Our rise is going to be 1, 2, 3, 4. Our m is 4 over 1, 2, 3. So 4 over 3. That's our slope. Now we need to write this into our point-slope form equation. So we have y minus y1. Let's use our zeros. So y minus y1, y1 is 0. So then we have 4/3, which is our slope, times x minus 0. Alright, now we need to get rid of these parentheses. So we're going to draw our box. So 4/3 goes out front. X minus 0 goes on top. 4/3 times x is 4/3 x. 4/3 times 0 is 0. So if we bring those down, and we bring y minus 0 down, we get y minus 0 equals 4/3 x plus 0, or minus 0, doesn't matter. Now to get y by itself, we need to add 0. If we add 0 to 0, we're left with 0. So we get y equals 4/3 x plus 0. Y equals 4/3 x plus 0. Or you could write it as y equals 4/3 x. You don't need to write that 0 at the end. That's our equation of the line of best fit. Alright, we got a couple more here. Alright, so first of all, we need to find two good points on our line. Let's look. Here we have our point. It's close but not quite on our line. Close but not quite. We could say this one is on our line. So there's one point. This point is close but not quite. Kind of far away. But we have an intersection here that our line goes through, so we can say there's a point there. So if we label these, this is going to go over -1 and down -1. So -1, -1. Here it goes over 2 and up 1. So 2, 1. Now that we have our 2 points labeled, all we need to do now is find our slope. So our m. So we can count this up. 1, 2. So our rise is 2. Our run is 1, 2, 3. So 2 over 3. Now we need to write this into our slope, or our point slope form. So y minus y1. Let's use 2 and 1. You could use -1, -1 if you wanted to. I'm just going to use 2 and 1. So we have y minus 1 equals 2/3, which is our m, times x minus x1, which is 2. Alright, so what we need to do now is we need to get rid of our parentheses. So we'll draw a box. X minus 2 and 2/3 goes out front. So 2/3 times x is 2/3 x. 2/3 times -2. Now this one will come out as a decimal, but that's okay. It should give us about -1 and 3, 2. Well, -1.32. So if we bring these down, we get y minus 1 equals 2/3 x minus 1.32. So we need to get y by itself. So we're going to add 1 because it's the opposite of -1, and add 1 to here. So we get y equals 2/3 x. -1.32 plus 1 would give us still a -0.32. And this would be an equation of the best, or the line of best fit. y equals 2/3 x minus 0.032. That is about what it would be. Alright, last one here. This word problem says, the table shows the number of girls signed up for a summer softball league each year for 5 years. So down here we have years since 2000. We have 2001, 2002, 2003, 2004, and 2005. 2001, 2002, 3, 4, and 5. And we have the number of players. 2001 has 105 players. So at 2001, we can go up to about 105, which could be right here. 2002 has 113 players. So 2002 go up, it's going to be a little bit more above the 105. Not much, but a little bit more above. 2003 has about 120 players. So we go from 2003 up to close to our line at 125, but not quite. Still a little bit higher. 2004 has 132. So go from 4 up to maybe halfway between these two. That's about 132. And 2005 has about 148. So 2005 go up to about 150, but not quite there. And we should get 148. Now, if we were to create a line of best fit for this, we would draw a line straight through our data here. So we did the A, we made the scatter plot. B, we need to describe the correlation. So this looks to me like it's going uphill. So every year, the number of players goes up. So we have a positive correlation. So for B, we would say it's positive. A positive correlation or positive relationship. C, it says predict the number of girls signed up for summer softball in 2006. So if this is the years since 2000, 2001, 2002, 2003, 2004, 2005, this would be about 2006. So what we're going to do is we're going to go from 2006 on our X, and we're going to go up until we hit our line. And we hit our line about there. Now once we hit our line, we're going to go over to our y-axis. And we found our point maybe to be about there. Now it looks to me like these are going up by 25 each, so 25, 50, 75, 100, 125, 150. So what this would be 175. Now it's a little bit less than 175, so we could say that our number of girls signed up for summer softball in 2006 could be about, let's say, 165 to 170 or so. Somewhere around there. It can't be 175 because it's not quite there, but it's somewhere around 165 and 170 if the number of players keeps increasing every year, like it has been. Alright, that's it for our lesson today. Go grab a worksheet.